Okay, this is 1.2 Roman numeral ionic compounds. For these, if you look on our periodic table, in the last video we talked about how group 1 has +1 charges, group 2 has +2 charges, and etc. But if you notice, I skipped over this section of the periodic table right here, which is called the transition metals. And the transition metals all have different charges. They don't have a set charge like these groups do. So what you have to do for those is when a transition metal is your cation, your the first element listed in a compound, you have to indicate the charge of it with Roman numerals. So we're going to do a few examples of that. So if you were given FeBr3, if you look on your periodic table, Fe is iron, that's a transition metal. So you write iron, and then Br is bromine, which again becomes bromide. Just like in the last video, you drop the ending and add IDE. And if you look on your periodic table, bromine is in group 17, which means it has a -1 charge. And since this whole part, if you look, has -3 because there's 3 bromines that all are -1, we know that iron has to have a +3 charge so that they cancel out to equal 0. So the way you write that is you write iron, and then in between iron and bromide, you write parentheses and write the Roman numeral of the charge. So this is iron 3 bromide. That's 3 as a Roman numeral. So do another example. Is going to be, say they give you TiCl4. Ti is selenium, and Cl is chlorine, which becomes chloride. And so if you look on your periodic table again, chlorine is in group 17, so that's -1 charge. That means this whole part back, this anion has a -4 charge, so that means selenium has to have a +4 charge, so that cancels out. And again, you just write 4 as a Roman numeral in between selenium and chloride. So you have selenium 4 chloride. And now, to go from the name to a formula, so say they gave you cobalt 3 iodide. Cobalt, on your periodic table, that's the transition metal, that's CO. Iodide is I, that's iodine. And if you look, it's indicated that cobalt has a +3 charge by the Roman numeral. So if this is +3, and we look at iodine in the periodic table as -1, you ask yourself, how many iodines do I need to cancel out the +3 charge? And of course the answer is 3. You need 3 iodines, so that this would be a -3 charge to cancel out this +3 charge. So the formula for cobalt 3 iodide is COI3. And now one last example is if they gave you mercury 2 oxide. Mercury on your periodic table is Hg, and we're given that it's a +2 charge based on the name, and oxide is oxygen, which if we look on our periodic table, that is a -2 charge. And so since the charges are the same, they already add up to 0, so you don't need any subscripts. So mercury 2 oxide is just HgO. And that's all for that.